question asks, a large heavy box is sliding without friction down a smooth plane of inclination theta from a point P. On the bottom of the box, a particle is projected inside the box. The initial speed with respect to box is u, and the direction of projection makes an angle alpha with the bottom as in figure. So this is a basic figure. So this is a box which is at an inclined plane whose angle is theta. A particle is projected from point P with initial speed of u and angle of projection. So here we are going to find out two things. First is find the distance along the bottom of the box between the point of projection and the point Q where the particle lands. So particle is projected from point P and it lands at point Q. So we are going to find out what will be the distance PQ. In the second part, if the horizontal displacement of the particle as seen by the observer on the ground is 0, find the speed of the box with respect to ground at the instant when the particle was projected. These are the two things which we are going to find. So first we are going to redraw the figure. So this is the inclined plane at angle of theta, a box in which a particle is projected from point P. So this is point P and it lands at point Q. The angle is alpha and this is initial velocity u. So first of all we are going to find out what will be the two components of the initial velocity u. So you can see that in x direction, let us call this as x and this as y. So in x direction the component is ux, which will be equal to u cos of theta. In y direction will be u sine of theta. Also we can find out the acceleration due to gravity component. So g will be in this direction and we will have alpha this. So this will be g cos of alpha and this will be g sine of alpha. So we are going to have x component as minus g sine of alpha and y component as a minus g cos of alpha. So first of all we are going to find out what will be the relative motion. So relative to the base, relative to the box, relative to the box, the component of the acceleration. So we can write this as a xb. So this will be equal to minus g sine of theta minus of minus g sine of theta. So this will be coming as 0. So x component with respect to box will be equal to 0. Similarly, we find out the y component with respect to box, which will be equal to minus g cos of theta minus 0. So a y b, that is vertical component, will be equal to minus g cos of theta. So let us say at any time t, the coordinate of the projectile or particle rather, the coordinate of the particle are x, y. and that is with respect to box. Here box is acting as a frame of reference. Frame of reference. So in horizontal direction, let us call this as distance x of x with respect to base is equal to ux with respect to base multiplied by t plus 1/2 ax with respect to base and t square. Now axp is already 0, so this will be 0, and let us say that sxb is given as x, so x will be equal to, and sorry, axp is 0, so this will be equal to, this is not 0, uxb multiplied by t, and we have uxb as u cos of alpha into t. We can say that x is equal to u cos of alpha into t. Similarly, we find out for y component with respect to base. So we write v yb into t plus half a by b t square. So vertical distance, if it is equal to y, so we can write y is equal to u sine alpha into t minus half g cos of theta t square. So as soon as this projectile P is launched from P, and as it hits the point Q, the vertical displacement will be equal to 0. So we can say that y is equal to 0. Putting here y is equal to 0, we get u sine alpha t minus half g cos theta t square is equal to 0. So from this equation, we can find out the value of t. You can see that t is equal to 2u sine alpha divided by g cos theta. We already know the equation of x, which is given by u cos of alpha into t. So substituting value of t in this equation, we are going to get u cos of alpha into 2u sine alpha g cos of theta. So we can write this as x is equal to u square 2 sine alpha cos alpha divided by g cos of theta. Now 2 sine alpha cos alpha is sine 2 alpha, so we can say that x is equal to u square sine 2 alpha divided by g cos of theta. So we found out the horizontal distance, that is the distance between point P and Q, which we are going to call as PQ. In the second part, in the B part, so let us say let V be the velocity of the box along the inclined plane, v being the velocity of the box along the inclined plane when the particle is projected. When particle is projected. And it is also given in the question that horizontal displacement of the particle as seen by observer, as seen by ground observer, is 0. So this basically means that the distance covered by the particle will be equal to the distance covered by the box. So we can say that distance covered by particle is equal to distance covered by box. So we can find out the velocity in, if the velocity of the box is v, then velocity in x direction, that is ux of the box, will be equal to minus of v, because we have taken x direction in this direction and box is sliding in the downward direction with the velocity v. That's why the horizontal component of the box, or x component of the box, will be equal to minus of v. Acceleration that is a of x will be equal to minus g sine of theta, and time will be same, 2u, which we already calculated. Time is equal to 2u sine alpha divided by g cos of theta. So we are going to use, and we also know one thing, that the displacement of the box will be equal to displacement of the particle. So we can say that displacement in x direction of the box will be given by minus, because it is in opposite direction, sine 2 alpha divided by g cos of theta. Now, using the equation, Sx is equal to uxt plus half axt square for the box. We put the value, we get minus v square sine 2 alpha divided by g cos of theta is equal to ux is given by minus v, time is given as 2u sine alpha divided by g cos of theta, and minus half g sine of theta and multiply by t square. So we get 2u sine alpha divided by g cos of theta and its whole square. So minus cancel out entirely, so everything will become positive. So we can write this as v square sine 2 alpha divided by g cos theta. This will be plus, now we get v 2u sine alpha divided by g cos theta, and this will be plus half g sine theta multiplied by 4 u square sine square alpha divided by g square cos square theta. So g is this square and 2 cancel out by this 2. So we get this as v 2u sine alpha divided by g cos theta plus u square, rather 2u square sine theta sine square alpha divided by g cos square theta. So from this equation we take common as 2u sine alpha divided by g cos of theta. So we are left with v plus u sine theta, sine alpha sine theta divided by cos of theta, and this is equal to u square sine square alpha divided by g cos of theta. Now u square cancel with u, g cos theta goes with g, and this square goes with this sine. So we are left with only here sine alpha is equal to here it is sine 2 alpha, not this. So let me expand it. So my apologies. Sine square. So this we can write 2 sine alpha cos alpha divided by g cos of theta is equal to 2u sine alpha divided by g cos of theta and v plus u sine alpha sine theta divided by cos theta. So 2 cancel out with 2, sine alpha goes with sine alpha, g cos theta goes with g, and u cancel with this square. So we are left with u is equal to, u cos alpha is equal to v, taking LCM, so we get v cos of theta plus u sine alpha sine theta divided by cos theta. Cross multiply, this will be u cos alpha cos theta is equal to v cos theta plus u sine alpha sine theta. So taking this to the left side and taking u as common, so we get this as u cos alpha cos theta minus sine alpha sine theta is equal to v cos of theta. Now we can very easily find out now the answer. So we get this as v cos theta is equal to u cos theta cos alpha minus sine alpha sine theta, and this is nothing but u cos of alpha plus theta. V cos theta is equal to this, so we can write that v is equal to u cos of alpha plus theta divided by cos of theta. This is the velocity. Thank you.